let's kick off today's special Ekahau webinar, the first one of 2024. We welcome you all back. It's so great to have you all here with us. We love seeing so many new people joining the webinar, and if you're a regular guest, welcome back. We've got a fantastic show on the road for you today with a industry legend himself, Ferney, and we're kicking off 2024 right. Building blocks Wi-Fi fundamentals of wireless. So that being said, Ferney, if you don't mind skipping to the next slide, Mac will do a quick round of introductions and then we will be handing the reins over to you, my friend.
Of course, of course. So first, thank you very much, Matthew. Let's start with the boring guys. So me and Matt, we are directors of ECSE and product marketing here at Ekahau, joined as always by Stu and Dale, sales engineers in America. But what do you have there? Something green on my small screen.
It's my Lego cup.
Oh, Lego cup. That's amazing. That's a little bit nerdy, Stu, isn't it? But we are joined by Ferney, and if you don't know Ferney, you will know him in a second. Ferney is a legend in the industry. Pretty much everyone in the Wi-Fi world knows Ferney for a reason. Not only he has amazing energy, but also he has connection to Colombian mafia. Was it Ferney, right? But most importantly, the knowledge about Wi-Fi is second to none. So Ferney, thank you very much for donating your time, buddy. And let's introduce yourself. How about that?
All right. Well, there's not much to me. When you're talking like a legend Wi-Fi, like, are you talking about me? Because I'm no legend. I'm just a Wi-Fi learner. Started doing technology a while back, and then as many of us, we ended up in Wi-Fi because somebody said so. And I'll just be sharing a little bit of what we share in class with all the community, worldwide community today. So you want me to just jump in, or what else? What's come next? You guys
let's get started because we've got a lot of content to get through today.
I do, yes.
Everybody, if you have any questions, please put it in the Q&A and we will, between myself, Max, Stu and Dale, answer as many questions as possible. And if we have time at the end of the webinar, we'll answer some questions live as well. But Ferney, over to you.
Thank you, gentlemen. Come from the wired side of things. As many of the people joining us today, probably, we are in technology, and at one point, we had to deal with a data closet like this, a wired closet that we had to clean up or troubleshoot and go and find problems. I used to work at a school district, and some schools had 12 of these data closets in them. Troubleshooting them was quite a challenge. And what I started doing out of desperation was cleaning them up in a way that it was easier to see, easier to clean, easier to troubleshoot. I had more space in between the switches, 2 rack units in between switches using short cables. I could see everything. That's a wired data closet, a wired network before and after. I started using different colors for the cables, where APs and cameras and devices that needed special attention. So I could show what I had done, and I could see a network and compare how it was before and how it is now. Now, we moved to these wireless networks. This is a professional development center. Lots of people sitting there, complaints about the Wi-Fi, it's slow, there are issues. So that's the wireless network before and after it was fixed. Computer lab, complaints about the students not being able to get in on time, having to log in again, kicked out. That's the wireless network after. These wireless networks we cannot see or touch or smell. These networks we cannot perceive with our senses. So we have to rely on tools, like in this case, we're going to be talking about Ekahau, that will help us better understand these tools. Now, of course, we're going to be talking about some basics of Wi-Fi. And we're going to be talking about Lego pieces, Lego sets. I used to like Legos a lot, until my children, I have 3 children, after they started leaving Lego pieces behind. And you wake up at night, to go to the bathroom, you're like, oh, you're stepping on things. But it's complicated when we come to these Lego sets. Of course, Ekahau is in the business of making things simple, easy. So we're going to be comparing some of these modules that we have in this Wi-Fi world to these Lego blocks. And yes, We're going to be building blocks. The complexities of Wi-Fi can be simplified in many ways. And yes, Wi-Fi is what we do. Wi-Fi is what we are in charge of buying and selling and troubleshooting and configuring. And Ekahau provides just a myriad of tools that will help us do this. But then one thing we have to understand, I mean, what better way to start the year, guys, that, talking about learning? Because as I was looking at some of the webinars earlier this year or at the end of last year, looks like a lot of people, their interest for this year, their resolutions will be to get trained and learn more. And we're all learning. There's so many pieces. There are so many parts and components that go into this. And let's just break, some of this down. We're going to use some of these blocks to talk about Wi-Fi and kind of like things that we as professionals in this industry should look at. What is Wi-Fi? Well, it is a technology that, of course, it started, some time ago, and there's so much to it. But Wi-Fi is just the preferred method to access the network, nowadays. And at the enterprise level, yeah, we're used to seeing some access points and devices connected to it, phones, tablets, whatever it is. And what we are trying to do is understand better how it works. So let's go back to basics. Let's talk about waves, because that is exactly what these really expensive $1,000 access points are doing. They're not sending data, they're not sending files, they're sending waves. These client devices, whether it's a tablet, where it is a phone, a computer, whatever it is, it's not sending data, it's not sending files, it's not sending videos, it's sending waves. So this OSI model, this is not unique to Wi-Fi. This is something that is a conceptual model in which if a device, for instance, is going to send a file, let's say if it's a Word document, and the application is how you're going to see that file on your computer, to be transferred, of course, is going to start going down this conceptual model, and the presentation layer is going to format that data in a way that it can be transferred, and then the session is going to maintain the sessions alive between computers. Now we move to layer 4, which is going to be a transport layer, and then you start adding headers, but it's going to be a TCP transmission or a UDP transmission. Then once it gets to a network layer, you start adding more headers, IP address, where it's going, the source, destination. It moves down to layer 2, which we start adding MAC headers. And then we go to the physical layer. In the case of a wireless transmission using Wi-Fi, the antenna is going to convert all those ones and zeros into waves, and using different modulation schemes is going to send more waves or less, more zeros or less zeros using those waves. In the air, once this transmission takes place, it's not data. In the air, it's not a segment. It's not a packet or a frame or a byte or a bit or a 1 or a 0. In the air is nothing. In the air is just waves. So we have to know some basics about these waves. Waves that we cannot see, we cannot touch, we cannot smell, we cannot sense those waves. So those waves are going to have certain characteristics, like the amplitude, how strong those waves are, the energy that they carry. That's going to be like the height of that wave. The frequency, how fast are these waves going? Well, they're all going at the speed of light, but the antennas will be cycling, 1 billion cycles per second or 2.4 billion cycles per second, sending waves. The way these waves are being transferred, of course, are going to have some effects based on the materials that you have surrounding the areas where you're designing Wi-Fi. Since you are just sending waves and receiving waves, that's what we're doing, then you have to know that these waves, as they go through space, they're going to attenuate, which is another word for weakening. These waves start getting weaker, and then, just go back here, there are many other effects that these waves are going to have. If you're designing, let's say, Wi-Fi in a building. Like, let me give you an example. We did a survey on a 3rd floor of a building in Pittsburgh. And as we did the survey, we noticed that there were some APs with the name AP09 something something. So I was like, what does the name mean in this? What's the naming convention? And they said, oh, don't worry about it. AP09 means that that's an AP on the 9th floor. We are on the 3rd floor right now. So I said, like, wait, no, I worry about it because what you're telling me is that we are seeing an access point from the 9th floor all the way down on the 3rd floor. Well, the AP was by the window. It sends waves. Those waves go across the street, hit the building across the street, and now they bounce, they reflect, and we can see these waves in different places. So we have to know the behavior of these waves in the environment. Yes, over free space, there are certain characteristics. Now, this is not unique to Wi-Fi, guys. This is just physics, you know. This attenuation of these waves, this weakening of these waves over distance just happens to everything. This is physics, to sound, light waves, Wi-Fi waves, and we have to understand this. Let's talk about some key performance factors. Because yes, Wi-Fi is simply waves being sent and being received. Knowing what these waves do in the air based on the surroundings. If you're in a warehouse surrounded by metal plates and metal ceilings and metal racks, then those waves are going to behave in one way or another. And then these waves, of course, when it comes to Wi-Fi, Wi-Fi has different methods to access the medium. It's very simple. It's like a conversation. Hey, Stu, or Jacob, or Dale. I don't know. Why did these guys turn the cameras off, man? Look at Matthew. Hey, Dale, how's it going, man? Oh, yeah, I don't feel so lonely now. All right. Yeah. So, guys, let me ask you, how were your holidays?
Man, my holidays were so
great.
Yeah, my holiday was pretty good here as well.
Yeah.
You know, we had that. Okay,
so
stop.
Good.
All right, so Wi-Fi is as simple as this. Happens that in Wi-Fi, only one device gets to transmit waves at a time. In here, we were sending waves, sound waves. Yes, having everybody sending sound waves at the same time doesn't work. So, Matthew, how was your holiday?
My holiday was fantastic, Ferney. How was your holiday?
Thank you. Mine was really good. We didn't get any snow in December, but we're getting snow now. My daughter was asking me last night, like, you know, why didn't we get snow on Christmas? Like, I don't know how it works. So that's how Wi-Fi works. Devices send waves, but they send waves one at a time. I know, very inefficient. But how can we make this process easier? Well, we first, on any design, we have to define the requirements. You as a Wi-Fi professional have to help customers define the requirements. Customers have it easy. What do they want? Wi-Fi. Where? Well, everywhere. For which device? Well, for all of them. What do you have? Well, we have laptops and iPads, and we have Chromebooks, and we have barcode scanners, and we have everything. So we need Wi-Fi to work everywhere for every device. Can you do that? Yeah, but you know, we as Wi-Fi professionals have to define and help the customers define these requirements better. Yes, there are some business requirements that the guys that are in charge of signing the checks and approving the project, those are the ones that say, hey, we need Wi-Fi. Okay, that's where we start. Now we have to start breaking it more, like asking questions, you know, like where do you need Wi-Fi and why? It's like a 5-year-old, like, why? Why do you need Wi-Fi? Well, because, you know, devices need to connect. Connect where? Well, to the application server. What's an application server? What type of application? And how many devices? And when are you going to be using it? And then we have to start asking for all those objectives and the purpose and all those things. Technical requirements, once we kind of identify, for instance, if it's a warehouse, just give you an example. I'm doing a warehouse in the Dominican Republic, and it's going to be for a place where they manufacture steel. So there's going to be like, ooh, as soon as they say like steel factory, like, whoa, man, metal everywhere, huge piles of metal. And they, of course, need devices to walk around and do this type of things. So you have to start identifying, okay, based on what you need, what type of access points do you need? Do you have the brand in choice in mind? And now it's going to get, I don't know, simpler or more complicated now that HP is buying Mist. Like, man, you know, we're going to end up, hey, did you hear the news that Ubiquiti is buying Cisco? No, I'm lying. That's not true. But hey, you know, you have to define APs and who is providing the antennas. This is an external antenna, external antennas. What are the requirement areas? Do we need Wi-Fi really everywhere? In the bathrooms, in the stairs? What do you need? So the regulatory domain is going to have an important role, because I know this is a webinar. We have people from literally all over the planet, guys? It's like pretty much everywhere. So yes, your regulatory domain is going to tell you what you can use and you cannot use. And yes, if you have companies that have multiple branches in different places of the world, then you cannot create a cookie cutter model that works in the US and everywhere. Like, no, because there are certain restrictions in other places. Yes, now we define all those things. We have also to define the requirements. Okay, what type of coverage do you need? And then customers, you're like, I don't know, I need Wi-Fi. What do you mean? You know, what's the coverage? I need Wi-Fi everywhere. Well, when they say I need Wi-Fi everywhere, what they're saying is we need waves from those access points to be delivered in these specific areas. And we need these devices that we are using in here to be able to receive those waves, understand what they mean, and be able to send waves back to the device that sent the original wave. So we have to define all those things. What's CCI? Well, we need to define the levels of interference that we can live with. What data rates, because everybody's going to have different requirements. You cannot design a Wi-Fi network that is going to work for everybody. Well, computers will be happy with Next 72, but maybe an iPad is going to require something else, a barcode scanner. All these things have to be defined. And yes, when we are designing Wi-Fi, we're not designing Wi-Fi for the access points, because we're always like, yes, the access points. My access points do everything. They have 4 spatial streams and 8 spatial streams, and they can do great. That's great. They can do L211A and L211B and L211G all the way down through Z. They can do everything. That's good. But what's more important is what can the clients do? Because that's the whole reason why we're having this conversation, because clients are the ones who need Wi-Fi. So we have to also help the customer identify the clients. And it is the client who's going to tell us what they need. If they need Next 62 or Next 65 DVMs of signal, if they have certain capabilities, that's what we have to pay more attention to. The least capable, most important device. It's different everywhere. Everybody's got different things in mind and different requirements. We have to identify this. That's when we define all the coverage requirements in Ekahau. When you're designing a network, you are designing to meet the requirements of that client. And then people like, okay, well, what do you need? Like, this device is Wi-Fi certified. See, on the back, it says right there, Wi-Fi certified. Okay, can it do 5 gig? Yeah, it can do 5 gig. Can it do Uni 1, Uni 2, and Uni 2 extended? Yeah, Wi-Fi certified. But it doesn't give us everything. Sometimes we have to dig and try to find that. Keep that in mind. It is the clients that you're trying to meet the requirements for. When you're doing a survey, a validation, site visit, because people are unhappy. Why are they unhappy? Because their clients are not connecting, because they're not getting the speeds they want, because their video or the audio gets all laggy, and like, you're trying to identify those issues. Think waves. We're just trying to figure out which devices are getting that coverage needed or not, because coverage, that's basically what we are providing initially. And that's what people have in mind. They need to have waves being delivered in these specific places. And then, of course, these waves, as they go through stuff, to walls and doors and windows and racks and bookshelves and everything, and people, you know, we are also attenuation areas. We are materials. And yes, if you're designing for a stadium or an auditorium, you can have 300 people there. Well, those waves will behave differently when the auditorium is empty, and they will behave differently when it's full of people. And yes, we have some baselines, some numbers out there, but just keep in mind that a brick wall is not 10 dB everywhere. Like, no, this is just a reference, because is it a brick wall built with clay and bricks in the northern hemisphere, or is it bricks built in the Dominican Republic or Brazil? All of these, the materials that are being used in a building, will define how these waves propagate throughout the environment. Secondary coverage. Why would we need secondary coverage? Well, for redundancy, for roaming, for capacity. One access point can cover, I don't know, a stadium. Hey, Matt, what's the biggest stadium in the UK? You're in the UK, right?
Yeah, it'll be Wembley Stadium. Will be the
Wembley
biggest.
Stadium. Well, Matthew, guess what? I can cover Wembley Stadium with one access point, but that's not enough. So we're going to need multiple access points covering. Of course, we don't want those covering everywhere. Secondary coverage is important for redundancy. You have one access point covering one area. It goes down. You need a secondary covering that space. For roaming, if you are walking around and you need to have multiple signals, you're going to have to be able to provide that. And signal to
Hey,
noise.
Ferney,
Yes, sir.
just to answer go back to your question about the biggest stadium in the UK is Wembley. The best stadium in the UK is the Emirates.
Oh,
Yeah.
man, you know what? I don't want to start any controversy here. Apparently, I didn't let you finish your statement. You're like, oh, I gotta finish this. All right.
I just think I might upset a few people in the comments in the chat. So
well, you deal with it, my friend. That's I'm out of that league. Okay, so signal to noise ratio. This is an important factor because here's what happens. You have signals and you have noise.
Ferney, your video is frozen for us for some reason, or I don't know if it's just for me.
You know what? Yeah, this is something with this. Hang on, let me freeze it and unfreeze it. There you go. How about now?
Was it the gestures thing?
Yeah.
Oh.
There we go. How come mine doesn't do it? I don't know. I haven't been able to figure this out, but sometimes you do thumbs up, you do hearts. Oh, look at how cute that is.
This is how I feel about
see,
everybody.
I froze right there.
Today.
Oh, look at that.
I don't know. There's something with my stuff. Let me just.
It's the thumbs up.
There we go. Yeah, I don't know. There's something with it. All right. So we have signal and we have noise. That's that gap in between the two. The larger it is, the better. If we have more noise, and now, well, let me just back here for a second. If I have a signal of neg 50 and noise of, let's say, neg 95, so the difference between signal and noise, in this case, is going to be 45 dB. Great SNR. You can send lots of waves and have, really good results with good SNR. But what if the signal gets weaker? Let's say our signal goes down to neg 65. And how about if our noise goes up to neg 75? Now we are left. The difference between signal and noise in this case is going to be 10 dB. Hey, Mateo, 10 dB SNR. How's that look?
Not so great. You might struggle with some voice calls or video calls. Might be okay for transferring just some simple data over Wi-Fi bus.
Yes, and here's the problem. When we're talking about signals and noise, it's just anything in the air. So if, for instance, I have my corporation network and I have, let's say, 50 access points in here. Yes, I can control my signals and I can control certain things, but in the air, whatever is in the air, that represents the overall noise for everything. So if you have access points from the hotel across the street and you have access points from the restaurant across the street, and all of those waves are in the air in your environment, all of that adds up to your signal to noise ratio. Of course, we have to talk about channels, because in here, we're going to have a certain number of channels that we can use. 2.4 is very universal. But 5 gig, there are certain regulatory domains that have, 25 channels that you can use. Others have 22, others have 19 or 20. And 6 gig, yeah, that's a whole other topic, because 6 gig is good. It has a lot of channels and more spectrum available, but not everywhere there are available. 2.4, it gives us channels 1, channel 6, and channel 11 for Wi-Fi. But happens that early on this game, they decided to say, like, okay, anything that is going to be used for industrial, scientific, or medical purposes can be used in this 2.4 gig band. And then other technologies like Zigbee, is going to be used in this spectrum. Bluetooth low energy. Bluetooth, we're going to have different. So all of these guys are using 2.4. That's added noise. 5 gig has more channels. Again, not everybody's got them. There are some DFS channels that are used for radar systems and stuff. Yes, if we can use them all, that's great. If not, you know, you're going to be limited. We're always trying to avoid interference. Interference is just, you know, another word for having like multiple APs in the same channel sharing the air. Any APs, not only your APs, neighboring APs, the APs from the office above, from the office below, all of those will play a role in this. Now we hit the spectrum, because yes, the spectrum is what we're using, the air. We're sending waves in the spectrum, and 2.4 got crowded quick. Why? Because the other technologies can use 2.4 without any license or special permits. Yes, there are certain restrictions, but then it got messy. And when you have multiple APs on the same channel, only one device, not only AP, only one device gets to talk at a time. Well, 5 gig, as it provided more channels and all the other benefits, that's good. But guess what? It also got crowded. It also got busy. That's when 6 gig came into play. We'll talk a little bit more about it, because 6 gig brings us a lot of spectrum that we can use. But we rely on regulatory domains, the government agencies, to authorize the use of those frequencies for Wi-Fi. So, my dear Mateo and Mark, I guess there's a quick break here for Paul.
Yeah, let the poll read the poll. So guys,
All right.
my Wi-Fi gets slow and bad. A, add, reduce, or replace my APs. B, reconfigure my existing APs. Or C, survey and review results on my own. Or survey and review results using Ekahau optimizer. Or if you have Ferney's number, I call Ferney.
Hey, if you don't have Ferney's number, I can put it in the chat. Don't worry. If you need to get hold of Ferney for some Wi-Fi problems,
go for it. You know, I get so many of those. I got one request one day. You would not believe this. A guy said, like, "Hey, Ferney, how do I create a report with 350 pages? Because I get paid by page." Like, whoa, that's easy. But yeah, always willing to help. That's another thing you have to do when in this learning process, is know someone. You know, you're not expected to know all the answers to all the questions. You sometimes just have to know those who have the answers. Not that I have all the answers, but hey, I'm always willing to help. And man, that's moving fast. Look at that.
Yeah, we've pretty much got a big percentage of the audience participating, answering the poll results. So I'll stop the poll and then share the results quickly. And hopefully you can all see the results, but the majority of you, which is really actually happy for us to see, is that you do a survey and review the results in Ekahau Optimizer. So fantastic that is the main answer. It would have been tough for me between that answer and calling Ferney, because I think I said in the chat earlier, but Ferney, I might have sat in your class now 4 or 5 different times, a different ECSE class. So any issue, I'm always like, "Hey Ferney, what's going on here?"
Always. Mac has also sat in my class a few times, huh?
Yeah, 5.
Maybe it was my accent. They didn't understand. They had to come back to understand it better. Like, can you say that again? Okay.
All right.
So happens that Wi-Fi is such a cool technology that governments in the world are struggling to keep up with all the requests. Like, hey, we need more. 2.4 is crowded. 5 gig is crowded. Then give us more. We use it in education. Wi-Fi is being used in space. It's using it in aircraft carriers. It's using in submarines. It's using everywhere. It's such a cool technology that even in nuclear power plants, they're trying to play. It's everywhere. That's undisputed. So please give us more spectrum. Let us use 6 gig. And then with 6 gig, we would have so many more channels, more spectrum, less interference. We can send waves in a different band that has nothing. So please, please. And the governments of the world started kind of like, you know, slowly, okay, we're going to let you use that with certain conditions, because you are not the owners of that. They belong to somebody else. There are other entities using this frequency. So beware that in your regulatory domain, now this is not a comprehensive list. There are so many more countries that have approved partial or full 6 gig use. So keep that in mind. So yes, we have the benefits of using more spectrum, but not everywhere it's available. Roaming is another key factor, because this amendments. If you have it on the access points, you could have it in the clients, and the clients and the APs talk the same language, have the same amendment. That's good. But if they don't, then you may have some problems. Now, remember that we're sending waves and receiving waves. The antennas play an extremely important role because those are the devices that will be sending those waves and receiving those waves and doing the interpretation. There are different types, internal, omnis. Hey, you notice that Cisco came out with that internal, like semi-directional one to bypass some of the AFC restrictions and stuff. That's really cool. But you have to know the antennas. You have to know the patterns. You have to know what those symbols and those graphs and charts and polar charts, however they want to call them, mean, because that's how we're going to guarantee that these waves go everywhere or that these waves are going to be sent on a specific place. Man, is it me or is it getting warm in here? It's like, whoa, let me just get my jacket.
Yeah, that's an amazing AP you're talking about there, Ferney. And if everyone stays tuned on the webinar, you might see something at the end of the webinar about us testing out that new AP somewhere.
Man, you keep teasing me, man. Like, okay, let's get to the end of the webinar. Costco, I don't know if you guys have Costco. Let me just tell you, Costco is a place where you can go buy a whole bunch of stuff you don't need. But, I've noticed, of course, we look at APs everywhere we go. Notice in Costco, we have like these very cold rooms where they have to keep things cold. They leave the access point in the outside and the antenna on the inside. AP has active components. It has CPUs, memory, and board. The antenna is nothing but a piece of metal on the inside. It doesn't have to be so strict when it comes to temperature. So know your antennas. There is a really good blog right there that talks about antennas. You guys get a snapshot of this, or you're going to get copies of these slides later anyway. Interferes. Lots of devices out there, microwave ovens, remote control toys, all kind of things that may interfere with these waves that we're sending in our Wi-Fi world. Security. Oh, this is not even a block that looks like a Lego set. I know. And when it comes to security, that 1X has nothing to do with Wi-Fi. I mean, it has everything to do with Wi-Fi, but this is not a Wi-Fi thing. This is security. And then, yes, we have to know the security because based on the protocol that you're using, these waves will be more secure or not as secure. These waves go everywhere. We have buildings like embassy buildings that will send waves all into a city, and cities sending waves into these embassies and important government agencies. And the security is one of the key factors that we have to keep in mind. And yes, in 6 gigahertz, you're going to be required to use WPA3. So those are pieces of knowledge that you have to keep in mind. This is just a summary of all these key factors. Now, there is the Wi-Fi 7, and it kind of goes in hand with marketing. You as a Wi-Fi professional have to know, not you marketing guys, you look at me like me, no, not you. Other marketing guys out there that sell APs and they promise people like, we got Wi-Fi 7. And then they paint this picture with rainbows and unicorns and say, yes, 46 gigs. We can get 46 gig with Wi-Fi 7. Everybody's asking, like, are they going to talk about Wi-Fi 7 in the webinar? Yes, of course, talking about Wi-Fi 7 now. And then why? Because that's the buzzword right now. And just last week, it was like certified. It's not even ratified by the IEEE, but there is a lot of documentation and webinars and things about Wi-Fi 7. And then now it's like, should I upgrade my Wi-Fi now or should I wait for Wi-Fi 7? Well, Wi-Fi 7's got a lot of, marketing stuff in it. Yes, 320 megahertz wide channels. Now we're down to, I don't know, 2 or 3 if we're using 6 gigahertz. But one of the big things is the multi-link operation. How do we get 46 gigabits? Well, if you use 2.4 and 5 and 6 gig at the same time, then you're going to be able to do that with 30 and 320 megahertz wide channels and 4096 QAM and 16, all this stuff we have to know because people will ask, if we're going to be using 2.4, well, I already show you, 2.4 is already busy. How about 5? Well, yeah, if 5 gig is busy, then basically we are down to using 6 gigahertz as this great improvement. But what if it's not fully approved in your regulatory domain? What if you don't have the 1.2 gigs that we got here in America? And many other countries got, 1.2 gigs of spectrum. That's great, but not everybody's got it. Some people got 480, 500, some have not received any. So keep those things in mind because we have to understand that. The tools, what tools are we going to use to understand this? Well, in this case, using the Ekahau Sidekick, that's a wonderful piece of equipment. It's got 4 nicks to listen to these waves. Because when you're doing a survey, my friends, you are walking and listening. Oh, look at you, Mateo. You got a Sidekick. Hey, I got my Sidekick right here too. Look at that. Dun, dun, dun. Mine's got a light on. Yours is off. So the thing is, this device has a spectrum analyzer. This device has really good sensitivity. It has a hard drive. You can store projects in there. And then when we talk about surveys, we are going out there walking and listening to the waves coming from the access points to build up those heat maps. There are different types of surveys that we can do. We can do stop and go. You can do continuous, that you collect data as you go around. We're just going to show here in a little bit the just go. And this is so cool just to do that. So with the Sidekick 2, when you walk, you collect these waves. Yes, the technology allows you to just put them all together and be able to identify the SSIDs that are used, that are not used, your APs, other APs, and there's so much that you can do with this data that you collect. So let me just here really quick.
Whilst you're getting that set, oh, there we go. We've had some amazing questions come into the Q&A. Don't worry, we'll answer them shortly. And oh yeah, on that screen you can see how much close attention to detail Mac pays to the slides after I quickly edit them, because just go survey. So easy, Mac can do it.
We'll make sure. Okay, my screen on your screen still, guys?
No.
Okay,
Okay,
see you on the screen, and Matt, I will be looking for an opening for you know, a joke about you, perhaps, maybe. We'll see later.
Okay, let's make sure that my screen is in your screen.
Yep, it's now
Okay.
broadcasting.
All good.
Sweet. Okay, let me hide this in here. Let me bring this guy out of there, and let's bring this. Okay, so I'm using the Ekahau survey app. Let me just bring my Sidekick over here. Okay. Yes, I could upload a project and a file and a map, but what if I don't have one? So when surveying, this is one of the cool things that Ekahau's come up with lately that will help our lives easier to collect this, because we struggle with floor plans pretty much everywhere we go. So if I have no floor plan, I can just go. So I just open the app, and all I have to do is as easy as this. I am now surveying the man cave. Not only surveying, look at the bottom portion. I'm building a map just by walking around and looking at things. Notice how this desk over here is also being built in there. As I walk, this iPad is using cool technology, LiDAR, it's using the camera, it's using the gyroscope, it's using black magic, and I don't know what else, but it's building a map as I go, and it detects, sends light waves and come back, and with LiDAR, it senses all of the surroundings, and it starts, oh, look at my chair. This is my favorite chair. I had to get it out of the house because my wife was like, get that junk out of it. Like, thank you, I'll take it to my man cave. So as I build this, notice at the bottom that even the obstacles, here's where my rack is, and all of that stuff is being built at the bottom. Okay, hopefully that's not too pixelated. And then let me show you something really cool. Not only inside a room, it will work. It will also, you know, if I come over here, let's see how far I can go before I get disconnected.
Wait, he just went outside, guys.
I'm outside, yes. Can you guys still hear me? You may.
Yeah, we can hear you. We can see you going around the back of the man cave.
Okay.
What's the attenuation of your mouse per name?
Real
Is it
quick.
hard?
Hope he's not going to get cold feet.
No, you've seen it here, folks. Just Go works in the snow. We're ready for the polar vortex.
just snow, baby, just snow.
Right, just snow.
Right, for the winter.
Just go with snow. I love it.
Hello, chickens.
Ah,
Oh, this is perfect. But notice how it's like it's easily capturing just even the solid objects. I mean, this is actually super cool because then it's getting the fence line, it's getting just around the objects out there. So it really knows no bounds. I mean, this is the technology here that the team has kind of put together for us is absolutely amazing. I mean, I'm every time I see this, I'm always
blown away.
yes, thank you. You took the words right there. Yes, thank you.
Done, and I'm back.
Welcome back, mate.
Okay, so let me end my survey, and voila! Angels sing. And now, without a map or anything, I just did a survey. Not only of the man cave, the outside of the man cave is also covered. Now, if I go to inspect, watch this. I could go back to all of the data that was collected as I was walking. Right now, I'm looking at the Home 5 survey, which is the SSID where I am joined. I can just change this to all networks. Now I can see all of the networks that I can see around my area, around the man cave, and all of these other places. So this is one of the coolest things that I can do because with no effort, just had the app, my Sidekick, and then boom, go, and I collected all of this data of the air. How are we doing time-wise, guys? I know you're like, okay, Ferney, hurry up, don't go walking, come back. So
we have 15 minutes. We're good. We're all good.
okay, we have time to like take a break. No, we don't have time for a break. We do, as we showed, it's really easy to do. As easy to walk your dog, huh? Well, we came out with this brilliant idea. Actually, I had guys, contact me and say, well, that's demeaning to us professionals in Wi-Fi. It's not as easy as walking your dog. So I don't know. This is kind of like, it's not that, because, that kind of undermines the work that these professionals throughout the world, are doing. They're getting training and buying the tools and everything. And a guy told me, like, it was actually from Mexico. He said, caminar un perro, no mames, güey. That's basically saying, like, yeah, walking your dog, just my boss hears that, he's gonna think like, why did we send you to training then if it's as easy as walking your dog? But it's that easy. I mean, you have to have the knowledge. You have to understand exactly what you're doing and how you're collecting the data. And all the beauty of it is going to be in collecting the data and analyzing it, because Ekahau does a tremendous job in doing that. So there are many other things, not only the survey portion. There's also the analyzer that has a whole bunch of other things that you can use. Of course, we don't have much time for everything, but then in here, you can see the spectrum. You can just walk around and gather all this data and see what's actually happening there. Now, the spectrum analyzer will not see the ones and zeros. The NIC will not see the spectrum. But sometimes you have to rely on the spectrum analyzer to identify some of those sources of interference. So let me just continue over here, because now I'm going to switch to a computer. There's the other great thing is that for like when you do a survey or a design, you can upload this to the cloud, to Ekahau Insights, and share. When we are designing a network, we have to validate. We have to corroborate and go on site and measure walls, measure distances, and gather what's in the air. Ekahau gives us all of those tools to be able to design solid network, to be able to validate that we meet the requirements, and to be able to troubleshoot any problems that you may encounter. Now, when is it time to do a redesign? Well, yes, you can just see how it is performing. Not always you have to just replace your network or your access points because your network's slow. Wi-Fi was designed since the beginning to go slow or to go fast. So we have to understand that if it goes slow, it's because maybe there are too many waves in the air from APs from other areas, from devices that are not Wi-Fi devices that are generating energy. So we have to be able to identify all those things. And for many organizations, you upgrade your network when there's, at the next budget cycle. Every 10 years, every 15 years, who knows? So you gotta decide and help your customers decide when it is time to do an upgrade. Ekahau has all the tools that will help you identify the time and identify the problems. Let me stop sharing here for a second. We have a couple minutes. Let me very quick share my other screen. Okay, any questions right now, guys, while I bring this up?
Everyone is just saying how much they love you, Ferney.
Oh, really? Thank you.
Yeah.
Okay, so now if I go to Ekahau Insights, let me just see what my Ekahau Insights is. So in Insights, you can share projects, not only surveys, but also design projects. And you know that if you have multiple guys in your organization, you can have guys drawing walls and things on the first floor while you do a second. You can collaborate in ways, and also based on the requirements that you have for your network, you can just use the optimizer. And then let me see, this will give you recommendations professionally tailored for your needs based on your requirements. You can identify, thanks to the analysis that the Ekahau does for you, and kind of give you pointers like, yeah, based on your requirements, your primary coverage can be improved. Or if you have lots of interference, like in this case, in my 5 gig, I have lots of interference. So this is how my network would look if I were to apply all these changes that Ekahau, the recommendations that Ekahau makes based on, of course, years and hundreds, if not thousands, of professionals that have put input into this. So this is one of the benefits that Ekahau Cloud and Ekahau will give you, so that you can improve the networks that are existing and design networks that are more solid. Now, guys, since we have a couple minutes, let me show you something really, really scary. Now, we are always worried about, like sources of interference and microwave ovens and things causing trouble. Well, yes, that's a fact. That's something that we worry about. If I is it tea time, Matt? Well, I'm from Colombia. It's coffee time. Let me warm up my coffee. So if I were to warm up my coffee, yes, it's pretty obvious that in 2.4, there are devices that are causing trouble in the spectrum, okay? That's Bluetooth, BLE, microwave ovens, remote controls, toys, all kind of stuff. But let me show you something really, really scary. Okay, Matt, if you get scared easy, I would recommend you drop from the call right now, because that I'm going to show you is really scary. All of these are things in the air in my 5 gig spectrum. See, that's an OFDM transmission, that's an access point. But notice, let me just actually disable this interference right here. Let me show you something really scary. See this? Those guys right there? Mac, does that look like a Wi-Fi transmitter to you?
No, wireless definitely, but not Wi-Fi.
It's not Wi-Fi, right? Too skinny, constantly, it's not waiting.
We're talking about Matt.
It's giving you the finger.
Yeah, so look, this really, really, really skinny guys. Well, watch this. My Sidekick is detecting things in the air. If I get the Sidekick, closer to my light, watch what's going to happen over here. It is the light. And what is the problem with that? Where are lights usually placed? Up in the ceiling. Where are access points usually placed? Up in the ceiling. Watch, I'm going to turn this light off. Watch. See, light goes off. This guy goes away. So yes, lights will have that. Now I have another 2 lights over there. They're not smart lights or Wi-Fi lights or anything. No, they're just stupid lights that are generating energy in the air that might affect my Wi-Fi transmissions. So let me stop sharing over here. I will switch to my iPad again. And My screen on your screen, guys?
Yes, come in now. We see
Almost
it.
there.
Sweet. All right. Okay. So 2024 is the year when Wi-Fi 7 gets certified. Everyone's got 46 gigabit now. We probably won't, but anyway, it's marketing. You have to know all that stuff. We have to know what's possible, what is not, because our customers are relying on us, the experts, to tell them, what to do and how to configure it right, and how to identify these sources of interference. And these other APs are not ours, but are causing problems to our waves. Think waves. We have to just think on the very basics of it. Sometimes we get tangled on our dashboard has this, and we have like AI, artificial intelligence, and then it's like so confusing. But go back to the basics. Education is key. I am learning Wi-Fi. I'm no expert. I'm no legend. I'm learning Wi-Fi, and we learn every day because there are so many pieces in this Lego set, man, that you just have to know how to put them together and how to get trained. Gentlemen, back to you. I know 1 hour is not enough. We have these 4-day classes, and 4 days is not enough. I know. It's just, is that how it goes? But Mateo.
Thank you very much.
Look at that. That's awesome, man.
Yeah, I know those guys.
Hey, so we have something very special for everybody in the webinar today. We are previewing something that we're going to be showing on the next webinar, which you'll be able to sign up for shortly after we've played you this video. But it's very exciting. It's we got to test out the brand new access point that Ferney mentioned earlier, the Cisco Meraki inbuilt directional antenna access point with the 6 gigahertz antennas. We are at a warehouse that is over 1 million square feet. So I'm going to play the video, and then we will come back after. Super exciting stuff. We're in a warehouse, and this rack in this warehouse is actually over 100 meters in length. And for the very first time, we are testing out 6 gigahertz using inbuilt directional antennas in the 9166D1 access point. So we're here in Germany, in L'Oreal, at this warehouse. And what we're doing, Matt?
Yeah, so we are doing a beautiful new redesign of a Wi-Fi network to make sure that we are future-proofed. And as you can see, we are bursting from excitement because this might be one of the first 6 gigahertz enabled warehouses in the world. So we've mounted the access point at 5 meters height to match the other mounting locations, possible mounting locations. On the other side of the warehouse, we have to mount it at 5 meters height. So we want to have them all mounted on the same height. How about angle of field?
So before we even came to the warehouse, we actually did a predictive design simulation in Ekahau AI Pro. And what we did is we mounted the access point with a -30-degree angle of tilt, because what we thought that would do is it would give great coverage directly below the access point, but also as you walk down the aisle and you get towards the other end of the aisle, you have great connectivity as you're moving down the aisle. And as you start to get towards the end of the aisle, this device, the client device they're going to be using here, it should then roam to the AP at the other end of the aisle.
Yeah, we actually measured that, right? So we've done the 6 gigahertz AP on a stick survey. So look at Matthew's screen, and you can see that towards the end of the aisle, we are dropping to around next 67 from the Sidekick perspective. That will translate to around next 75, next 77 from the barcode scanner's perspective. And that means that it will roam inside the aisle. And when you go around the aisle, you won't drop off. You're ready for very fast roaming. You can even run around the warehouse and you won't drop off. So you are ready for the AR and VR in this beautiful environment.
Exactly. So we measured it with our Sidekick 2 using the survey app, and that's how we can see this lovely heat map coming from this access point. And then the last thing that we're going to do, we've got one of the barcode scanners here for what they're going to be using in the warehouse, and we're going to test it connecting to the access point as we move down the aisle, compare it to the Sidekick so we can get that offset measurement. So what do we call it? The
LCMI?
Yes.
Least capable, most important device. That is apparently me, right?
Otherwise known as Mac.
Awesome.
So if you want to get yourselves signed up to this very special webinar, we are going to be doing a full episode on everything from redesigning that warehouse to improving and optimizing the existing Wi-Fi there, and all of the challenges that come around a 1 million square foot warehouse Wi-Fi design, including best practices for 6 gigahertz and future proofing. So we'll leave the QR code up on the screen for a few minutes time just to let everyone get a chance to register. We're extremely excited for this one, and I think you're all going to love it. So do make sure you get yourselves signed up.